Assalamualaikum and good morning to all of our students. So today we are going to finish our last subtopic in chapter 5, which is 5.7 Properties of Ionic Compounds and Covalent Compounds. Okay, before we proceed, as usual, you're going to have a riddles. So I have prepared two questions for you. So the first one is, can you find the thief by just looking at the picture? Okay, can you find the thief by just looking at the picture? Okay, and then next question is, what do you see in the picture? What do you see in the picture? Okay, I'm gonna give you the answer in the middle of our lesson. Okay, so please be prepared with the answer. Okay, so our learning standard today is at the end of the lesson, you should be able to compare the properties of ionic compounds and covalent compounds through experiment. And the second one is, explain with examples the uses of ionic compounds and covalent compounds in daily life. Okay, so we have one experiment in this subtopic, and the experiment is to study the difference in properties between ionic compounds and covalent compounds. And under this experiment, you have three more parts, three more small experiments, which is A, to find the electrical conductivity of compounds, B, to find the solubility of compounds in water and organic solvents, and C, to find the melting point and boiling point of compounds. Okay, since we are in MCO, so we cannot conduct the experiment. Okay, so let me explain the conclusion briefly, for now. So we will do the experiment in school once the school reopen. Okay, for A, just now the small experiment I said, for A, to find the electrical conductivity of compounds. So the conclusion is, ionic compounds can conduct electricity in molten state but not in solid state. Covalent compounds cannot conduct electricity in all states. Alright, for B, to find the solubility of compounds in water and organic solvents. So the conclusions are, ionic compounds are usually soluble in water. Covalent compounds are usually soluble in organic solvents. For C, the conclusion for C, to find the melting point and boiling point of compounds. Ionic compounds have high melting point and boiling point, and covalent compounds have low melting point and boiling point. We will go into details after this. So we straight away go to the discussion of the experiment. So there are two questions from the experiment. The first one is, what type of compound is lead bromide, magnesium chloride, and naphthalene? Number 2, predict the electrical conductivity, solubility, melting point, and boiling point of sodium chloride. So the first answer is, lead bromide and magnesium chloride are ionic compounds, whereas naphthalene is a covalent compound. Number 2, sodium chloride can conduct electricity in molten and aqueous forms, dissolves in water but cannot dissolve in organic solvents. Sodium chloride has high melting point and boiling point. So what's the difference between molten and liquid? So molten is formed from melting a substance that is solid at room temperature. But liquid is already existing in the liquid state at room temperature. And aqueous forms means it's a solution in which the solvent is water. Right, so now we look at the electrical conductivity. So based on the experiment 5.1 just now, ionic compounds and covalent compounds have different electrical conductivity. Ionic compounds cannot conduct electricity in the solid state but can conduct electricity in the molten state and aqueous solution, while covalent compounds cannot conduct electricity in all states So there are three parts explaining about this. Okay, the first one is this one. Okay, it explains why ionic compounds cannot conduct electricity in the solid state. Okay, so this is solid ionic compound, right? Okay, and look at the explanation. Ions cannot move freely because they are tied by strong electrostatic attraction forces. Therefore, solid ionic compound cannot conduct electricity. Okay, so this is in solid form. Okay, so ionic compound cannot conduct electricity in solid state. Alright, look at the second part. Okay, so this explains why ionic compound can conduct electricity in molten or aqueous solution. So this is the molten or aqueous solution of ionic compound. Alright. So these are the ions. Okay, ions can move freely. Okay, because electrostatic attraction forces have been overcome. Okay, so molten or aqueous solution of ionic compound can conduct electricity. Okay, so look at the part 3. Okay, and this explains why covalent compound cannot conduct electricity in all states. Okay, so this is solid or molten covalent compound. Okay, so these are the molecules. Okay, so molecules in covalent compounds are neutral and do not carry any charge. Okay, so therefore covalent compounds do not conduct electricity in all states. Okay, because they are neutral, right? Okay, so cannot carry any charge. Okay, now we look at the solubility in water and organic solvents. Okay, most ionic compounds are soluble in water but are not soluble in organic solvents. On the other hand, most covalent compounds are not soluble in water but are soluble in organic solvents. Okay, it's vice versa. Okay, when dissolved in water, water molecules help to overcome electrostatic attraction force between ions and break down the lattice structure of the solid compound. As a result, ions can move freely in water. So what is lattice structure? Okay, so we look at it now. Okay, so lattice structure is the orderly arrangement of atoms, ions or molecules of a compound in a solid crystal. Okay, so that's the meaning. Okay, so this picture explains why most solid ionic compounds are soluble in water. Okay, so look at the literacy tips first. Okay, in a water molecule, oxygen atom has a higher electronegativity than hydrogen atom. So this causes the electrons shared in the covalent bond to be pulled towards the oxygen atom. Okay, because of the electronegativity. The unequal sharing of electrons creates partial negative charge at the oxygen atom and partial positive charge at the hydrogen atom. Okay, alright. So look at the explanation above here. The figure below shows the solubility of sodium chloride in water. Okay, so water is a polar solvent that has partial negative charge at the oxygen atom and partial positive charge at the hydrogen atom. So this explained just now. And then a positive ion natrium plus will be attracted to the oxygen atom of water molecule which is negatively charged, while negative ion chlorine will be attracted to the hydrogen atom of water molecule which is positively charged. Okay, attraction force between atom of water molecules with the ions of ionic compounds are strong enough to overcome electrostatic attraction force between ions themselves. So this enables more solid ionic compounds to be soluble in water. Okay, so look at this, the picture here. This is the water molecule. Okay, and you can see it's a partial positive charge at hydrogen and partial negative charge at the oxygen atom. Okay, so chlorine ions okay, are attracted to the positive side of water because it is negative. Negative will attract to positive, right? Okay, and sodium ions, okay, positive charge, are attracted to the negative side of the water. So positive will go to the negative. Okay, organic solvents cannot overcome electrostatic forces between ions in a solid ionic compound. So ionic compounds are not soluble in organic solvents. Okay, molecules in a covalent compound are neutral and do not carry any charges. So molecules in a covalent compound are soluble in an organic solvent but not soluble in water. So that's all for solubility in water and organic solvents. Okay. Okay, now we go to melting point and boiling point. Okay, so ionic compounds have a high melting point and boiling point. Therefore, ionic compounds are not easily volatile. So what is volatile? So volatile means turn into a gas or vapor, right? Okay, so this figure shows that ionic compounds have high melting point and boiling point. Okay, so the reason is, okay, this is sodium chloride. Okay, ionic compounds. So an ionic compound like sodium chloride consists of positive ions natrium and negative ions chlorine. Okay, so that attract one another by strong electrostatic attraction forces. So high heat energy is required to overcome the strong electrostatic attraction forces so that the ionic compound can melt or boil. Thus, sodium chloride has a high melting point and boiling point. Okay, so what about covalent compounds? Okay, covalent compounds with simple molecules have low melting point and boiling point. Hence, covalent compounds with simple molecules are easily volatile. Okay, easily volatile to vapor. Okay, alright. So the figure, covalent compounds with simple molecules have low melting point and boiling point. Why? Okay, so look at the explanation. Van der Waals attraction forces, this is van der Waals attraction forces, okay, between simple molecules in covalent compounds like methane, CH4 are very weak, okay, hydrogen and hydrogen, okay, so it forms van der Waals attraction, so the attraction is weak, okay, that's why a low heat energy is required to overcome the weak van der Waals attraction forces so that the covalent compound can melt or boil. Thus, methane has a low melting point and boiling point. Okay, so why lizard can stick to the surface of walls? Okay, of course you have seen a lizard, at least in your house, right? Okay, lizards can stick to the surface of walls, okay, because the reaction between some electrons from the molecules of the hundreds of fine hairs found on the sole of the lizard's feet and some electrons from the molecules of the wall. Okay, so this reaction forms the electromagnetic attraction known as van der Waals attraction forces. Okay. Okay, back to the riddles. Okay, so this is the first riddles I asked you. Can you find the thief by just looking at the picture? So the answer here is the lady sitting in the chair has the detector attached to the back of her blouse. Okay, wonder why? Wonder how she can escape from the mall. How she escaped from the mall. Okay, so the second riddles. Okay, what do you see in the picture? Okay, you have seen this earlier. So the answer, if you concentrate on the black portion, you will see the word good, right? Okay, within inside, you will find white spaces concentrating on which you will see the word evil. Okay, so the picture represents that the whole concept of good can't exist without the evil. Okay, alright, that's all for the riddles, and now we continue our lesson. Okay, now we come to structure of covalent compounds. Okay, so covalent compounds, alright. So in covalent compounds, we have simple molecule like this, water and carbon dioxide. So the example of a simple molecule, and we have giant molecule. Okay, which is silicon dioxide. Okay, so this is the silicon, this is the oxygen. Okay, and between them is covalent bond. So this is giant molecule. Okay, and this is a simple molecule in covalent compound. Okay, so it's still in covalent compound. Okay, so the structure for simple molecules, it is small and simple structures can be found in the form of solids, liquids or gases. Okay, while the giant molecule, okay, the structure is a very large structure, usually exists as solids. Okay. Okay, and the chemical bond, for simple molecules, covalent bonds are strong in the molecules and the van der Waals attraction forces between molecules are weak. Okay, because the covalent bonds are very strong. Okay, for the giant molecules, strong covalent bonds in the molecules only. Okay, no van der Waals attraction forces between molecules because of its giant structure. Okay, the last one is melting point and boiling point. Okay, for simple molecule, it's low because only little heat is required to overcome the weak van der Waals attraction forces between molecules. Okay, for the giant molecules, it's high because a lot of heat is required to break the strong covalent bonds. So these are the difference between simple molecule and giant molecule in covalent compounds. Okay, so now we come to the final part, which is uses in our daily life. Okay, so in industrial sector, okay, the ionic compound of lithium iodide is used in batteries. Okay, paint contains covalent compounds such as pigment and turpentine solvent. Okay, the second sector is agriculture sector. The ionic compounds of ammonium nitrate, okay, and potassium chloride are used in fertilizers. Okay, and pesticides used to kill weeds and insects contain covalent compounds such as bromothane and chloropicrin. Okay, chloropicrin. Next, in medical sector, okay, so the ionic compound of sodium bicarbonate is used in antacids, okay, antacids to relieve gastric pain. Okay, and paracetamol is a covalent compound used to treat fevers and irritation. Okay, and the domestic use, detergents contains the ionic compound sodium chlorate, which is used for domestic cleaning. Okay, and glycerol is a covalent compound added to skincare products to moisturize skin and help to prevent dry skin. Okay, so that's the examples of the uses of ionic compounds and covalent compounds in our daily life. Okay, so end of our lesson today. So please do test yourself 5.7, page 130 in your chemistry textbook. Okay, so these are the questions. Okay, try to do on your own. Okay, and then you can check your answer on your own because I put the answer in this slide, right? So you can check on your own, and don't forget to send me your answer. Yeah, okay, thank you, see you next time.